Good afternoon, everyone. I want to welcome you to my lecture today. Of course, today we basically going to focus on mathematical expectation, part 3. We started this on Monday, but let me tell you this: the next Monday will be dedicated to Meter 1 practice questions review. So the whole thing that we're going to do on Monday is just to walk you through the Meter 1 practice questions, to also give you information about which areas will be covered and what the materials to take to the exam, to bring to the exam. So I hope you're all going to be in attendance. So I want to once again welcome you to this topic, mathematical expectation part 3. And of course, in the outline, I'm going to walk you through expectation of products, covariance, correlation, approximation of nonlinear function, then Chebyshev inequality. Well, let me tell you, maybe depending on time, we may, maybe out of the 5 objectives I'm showing you now, we will only cover 1 to 3. So the remaining 2 objectives will be achieved on Wednesday. Because Monday lecture, it's just going to be Meter 1 preview. Okay, so we're still working with the random variables, X and Y. The other time, when we started mathematical expectation, I actually walk you through how you can compute conditional means, unconditional means, conditional variances or conditional variances, conditional standard deviation and unconditional standard deviation. And you will actually see that all of that involve expectation, whether we're talking about the expectation of X or the expectation of S squared. But what I'm displaying now is when we're talking about expectation of the products. You know, I have S and Y, okay? They are random variables, and they have a joint probability distribution that we can actually call discrete or continuous, depending on the state space of X and Y. So we have a random variable G of XY with a corresponding joint probability function F of XY, because the G of XY means you have a combination of X and it's a function of X and Y that is a random variable. But this time around, a product. Okay. If X and Y are discrete, if I'm seeking to get the average of the product, that will involve a double summation. That's why you see 2 summation. And the random variable, what is the random variable here? G of XY, which is XY, X multiplied by Y. What is the F of XY? That is a joint, PMF. But if X and Y are continuous, the only thing that is going to be different is just like the summation sign will change to integral sign. We're going to have 2 integrals. And of course, we're going to have the X, the Y. What if I'm talking about the product of X, Y, Z? Like if I have 3 variables, and if each of them is a discrete, I'm going to have triple sum. If it's continuous, I'm going to have triple integral. I just wanted to take note of that. We're going to kickstart, considering a discrete situation. Take a look at what we have now in terms of a table, X and Y. Okay. You have the state space of X is from 0 to 2. The state space of Y is from 0 to 2. That is going to be 3 by 3, right? Which means the numbers of possible probability that you're going to have in the cell is going to be 9. 3 by 3, that will be 9. Now you have the table. Of course, in the table, I've walked you through different kind of stuff, how you can get the marginal function of X, marginal function of Y. Okay, I mean the marginals. Then what if I want to find the expected value of the product XY? Because I'm dealing with the discrete, this guy is going to be double sum. And in each sum, I'm basically going to consider the state space of the random variable. 0 to 2, 0 to 2, as it is being displayed. XY, don't forget, whatever you have inside the expectation is what is going to act as a random variable. What we have inside the expectation here is X and Y, the product of X and Y. And that is what you see as a random variable, XY. So all what you're just going to do here is to just like 0, 0, 0, 0, 0, 0, 1, and so on like that. How many cells you're going to have? 9 cells. And whenever you are doing that, you're going to multiply each cell by the corresponding probability, which is going to be the probability of the join. When I'm talking about when x equal to 0, y equal to 0, then I will use a probability associated with s equal to 0, y equal to 0, which is basically 3 over 28. And so like that. Then I'm going to add them up. Then I got 3 over 14. That is the expected value of a product. Any question on how to get the expected value of a product? Any question? You're good, right? Okay. That is how to get the expected value of X of the product. Now, let me tell you this. What if you are given a question like this and they want you to investigate whether X and Y are independent? Do you know that if I'm able to get the expected value of X and the expected value of Y, do you know that if the expected value of the products equal expected value of X multiplied by expected value of Y, X and Y are independent? Do you know that? There's a lot of ways we can show that. Do you know this another way? When the expected value of S given Y equal to expected value of X, that's another way to show independence. When the expected value of Y given X equal to expected value of Y, that's another way to show independent. Do you know that if the probability of XY equal to the probability of X multiplied by probability of Y, this is a possible way of showing independence. And so I just wanted to take notes of that. Okay. In this theorem, we want to talk about, go ahead. Oh, it's X times Y, which is that's a good question. What is happening here is products. That's a good question. Okay. Now, when I have S and Y, we may actually consider doing algebra with S and Y. What are the algebra that we can do with S and Y? Multiplying it, that's why we have XY. Adding it, that is what we want to do now. Or subtracting it, that is what we want to do now. Look at that. So which means what I just showed you before now, what I show you here is how do we get the expected value of a product. What I want to show you now, how do we get the expected value of the sum of X and Y and of the difference between X and Y. Look at that. And we have a rule. Expected value of x plus y is the same as the expected value of x plus the expected value of y. The same thing also applies to expectation of the difference. So this very rule actually hold. Now, if you want to know the application of what we're talking about, why do we need to add? In a real life practical situation, when do we add two variables? When do we subtract two variables? When do we multiply two variables? I'm going to tell you this. In multiplying two variables, we are going in a way to investigate the relationship between the two variables. That is why you want to consider the expectation of the product. Because the expectation of the product will enable you to obtain the covariance. The covariance will enable you to compute correlation. So correlation actually measures the relationship between two variables. Do they have any connection or not? But if I'm talking about the sum, when do I add variables together? Take a look at this example. If X represents the daily production of some item from machine A, and Y the daily production of the same kind of item from machine B. In your company, you have two different machines that are producing the same thing, which means if you're interested in the total number of items produced, you're basically going to add, right? The one from the machine A to machine B. But let me tell you, when you add that up, that total is a random variable. Why is it a random variable? Because the totality from the two machines varies from day to day or from operation to operation. Because of the fact that there's a variation. We live in a stochastic environment. And that was why I said the X plus Y represent the total number of items produced daily by both machines. Because that sum is a random variable, then we need to be able to, that is why we're seeking to get the average. That is why we need expectation of X plus Y. Because the X plus Y, that is a total production, varies from operation to operation because of the fact of, there's a normal variation inherent on any activity. Okay, I think I justified that. Okay, now I think I've walked you through the example of how to obtain the expectation of a product using the continuous, when the X and Y are discrete, but when they are continuous, expectation of a product, X and Y. I want you to look at theorem 4.8, is what I stated here. When the expectation of a product is equal to the product of the unconditional expectation, then the S and Y are independent. Okay, the S and Y, don't forget, the S and Y are independent in the case of the machines, machine A and machine B, if it means what this machine is producing is independent of what the other one is producing. That is what we mean in a situation whereby expected value of SY is not equal to that, then it means what machine A will produce depends on the machine B. Now, definition 4.2, that is how to figure out the expected value of XY when X and Y are continuous. Okay, that is exactly what I'm showing. And, what I'm proving here is when X and Y are independent, do you know we can actually separate the integrals? We're going to, we got two integrals. Why? We were separating the integrals. What is basically going to happen, in one integral, I'm going to have X. In another integral, I'm going to have Y. And in that situation, the f of XY can be broken into f of S and f of Y, so that the f of S is going to go with S, f of Y will go with Y. Then I can actually, in the process, That's the first one is going to be the expected value of x. The second one is going to be the expected value of y. This is a derivation to show that the expectation of a product is equal to the product. I mean, is equal to the product of the all conditional means. We want to go into an example now. Go ahead. Okay, this is what happened. Do you see f of x, y, right? If x and y are independent, what will happen to f of x, y? If they are independent, this is what is going to happen. Now, let me write this. Integral, negative infinity to infinity, negative infinity to infinity, x, y, f of x, y, dx, the y, right? Look at this guy. If x and y are independent, f of x, y will be equal to f of x, f of y, right? Then what I'm going to have now, negative this to this, negative this to this, x, y. So this guy is now going to be just f of x, f of y, dx, dy. Then if this is what happened, then I can collect like terms. I can do negative infinity to infinity, x, f of x, dx. Negative infinity to infinity, y, f of y, dy. What is this guy? What is this guy? This guy is expected value of x. This guy is expected value of y. That's what we mean. For what? From here? Of course, you can always do it because you can collect the like terms. X, f of x, ds in one integral. Y, f of y, the y in another integral. That's possible. That is, yeah. But that, do you know what we broke down? This guy, the joint into this. But there's a condition to go from here to here. That is if x and y are independent. Okay. Now, we have a question now, example now. It is known that the ratio of a gallium to, arsenide does not affect the functioning of gallium arsenide wafers, which are the main components of microchips. Let X denote the ratio of gallium to arsenide and Y denotes the functional, wafers retrieved during a 1 hour period. X and Y are independent. See that instruction? They've already told you. Pay attention. X and Y are independent random variable with the density function, which means they've already given you the idea that that joint is the same thing as f of x multiplied by f of y. Now, you're given this as the joint. The state space of x is from 0 to 2. The state space of y is from 0 to 1. And what do we want to figure out? You want to obtain the expected value of x and y. Why do I start with that theorem? Because I have been told in the question that x and y are independent. That was why I actually put it that way. So which means if x and y are independent, what the expectation of x, y will give me is the same thing as the product of the all conditional means. Okay, that is why. Is anybody? Who need clarification? Go ahead. Oh, the E of S, that's a good question. You can do. You know why? Look at S squared. Y into 1 plus 3y squared. They can go together in one integral. Do you see that? You can separate. Then you are now left with 1 over 4, right? Then what can you do to 1 over 4? You can, one can have 1 over 2. The other one has 1 over 2. Does that make sense? Do you see what I'm saying? You know, he asked a question that you can't really separate. And I say, yes, you can. The only way you cannot separate is when you have x plus y or s minus y. But right now, look at that. If I want to separate this now, you know what I'm going to do? If I want to separate, okay, one, do you know that my f of x is 1 over 2 s squared? My f of y is 1 over 2 y into 1 plus 3y squared. Do you see the separation? That is the separation. Does that make sense? But if you don't want to go by what I've done, if you want to waste time, you can just do this. You already know how to get what is f of x. Integral f of x y dy. Range of y. Or range of y 0 to 1. Get your f of x. Do the same. Do the same for f of y. Okay, f of xy dx. The range of x is from 0 to 2. That's another way you can figure each of that out. Okay, so I think I just demonstrated that to you now. You can see that. Okay, any question? You good, right? Okay, go ahead. Oh, okay, I find it here of x. Okay, now let's say you are giving f of xy, right? You know that if I want to get e of x, I need f of x. So if you obtain this guy from the joint, like what I'm trying to tell you now is this. You know, if I want to get f of x, it's going to be 0 to 1 s squared y 1 plus 3 y squared over 4 the y. What is the range of y? Let me see. The range of y is from 0 to 1, right? Now from here, you know, y is going to disappear because the range of y is from there, right? You're going to get f of x. Now, the moment you get f of x, then you can now find this guy, x, f of x, dx. What is the range of x now? 0 to 2. So this is how you're going to get your expected value of x. But you four of us need f of x, which is going to come from here. Does that make sense? Okay. You do the same thing for f of y. You get the expected value of y. Okay. And do you know another way you can investigate? You can, if you have this f of x, you can also compute f of s given y. If this guy and this guy are the same, then expected value of, x and y are independent. Okay. We want to go into theorem now. If you look at theorem 4.9, I have a linear combination of x and y, okay? And I want to obtain the variance. I have a linear combination of x and y, and I want to obtain the variance. Okay, when you take a look at maybe z equal ax plus by, the a and b are constants. A and b are constants. And I'm seeking to get the variance of z. Okay. Now, the variance of this guy now, okay, is basically going to be constant squared, variance of x, constant squared, variance of y. Do you know I'm supposed to have plus 2? Do you remember this? Like if I have a plus b all squared in mathematics, right? You know, you're going to have a squared plus b squared plus 2ab, right? Now, why is it that I did not consider this? Because if x and y are independent, okay, then the covariance will be equal to 0. The covariance of x and y will be 0. How? This is the covariance. I'm going to show you now. The covariance of X and Y is expected value of XY minus expected value of X, expected value of Y. When this guy equal to this guy, what happened to the covariance? That will be 0. When the covariance equal to 0, you know what? We know what that means? Relationship does not exist between X and Y. They don't depend. That's what it means. Okay, so the theorem 4.9 is trying to tell you that if I have a linear combination of X and Y, and I'm seeking to get the variance, that is it. Now, what if the linear combination is AX minus BY? It doesn't matter whether minus or that. You know why? Because this is I'm going to show you something now. Let's say Z equal to let me say is Z equal to minus 4x and Z2 equal to 4x, and I want to find the variance of Z1, that is, I want to get the sigma 1 squared, and I also want to find the variance of Z2, which is that. You know what variance is going to do? The variance, the coefficient of X, you're going to square that. Minus 4 squared. So here, minus 4 squared, then the sigma square X. Here, 4 squared, the sigma square Y. The sigma square X, the sigma square X. Now, this guy is the same. That is why when you are subtracting or you are adding, is the same. But do you know the difference? When X and Y are not independent, the difference is basically going to be, so I'm going to show you now. I'm going to show you the difference now. Okay, if I'm considering variance of X plus Y, it's basically going to be the variance of X plus the variance of Y plus 2 covariance XY. If I'm talking about the variance of X minus Y, is going to be the variance of X plus the variance of Y minus 2 covariance XY. You see the difference between the difference between the two is when X and Y are not independent, this is going to be a plus, this is going to be a negative. But when X and Y are independent, the covariance will be equal to 0. And that is why they both going to be the same. That is what I'm displaying now. Any question? Okay. And I want to generalize. What if I have more than 2 variables? X1, X2, X3 up to Xn, they are independent. And I basically want to find the covariance. I want to find the variance of that. Then I'm basically going to have that. So we are generalizing now. Any question? That's a generalization. This is an example. If X and Y are random variable with variances, the variance of X equal to 2, the variance of Y equal to 4, the covariance equal to -2. Take a look at that. What we use to denote covariance is sigma XY. When the reason why they give you, when the covariance is -2, what are they trying to tell you? X and Y are not independent. When the covariance is not 0. When the covariance is 0, X and Y are independent. When it is not, X and Y are not independent. Now, they want you to figure out what is the variance of a linear combination Z, where Z equal to 3X minus 4Y plus 8. But there's something I want to tell you. There's something I need you to know. If I'm seeking to get the variance of AX plus BY plus C, take a look at it. A, B, C are constants. This is the same thing as the variance of AS plus BY, because a constant does not vary. Something is a constant, right? It doesn't vary. Therefore, the variance of something that doesn't change will be equal to 0. And that is the reason why this guy is the same thing as this guy. And that's exactly what we're applying on the board. Look at, you got a z equal to 3x minus 4y plus 8. So which means if I'm seeking to get the variance of that, it's the same thing as seeking to get the variance of 3x minus 4y, because that very 8 is a constant. It doesn't have any variable. Any question, all what you're just going to do is to plug in. What formula am I using here? I'm using the second one because we're talking about negative. And that's why you're going to have a -2 covariance. Look at that. -2 covariance. And don't forget, your covariance that was given was -2. That was why you have a -2. Therefore, the variance of the z is basically 130. Any question? Any question? Super easy, right? Math is just about following rules. Then when you're following rules, you're basically going to be fine. Now, I want to walk you through the covariance now. How do we get covariance? When we're working with discrete and when we're working with continuous. Do you know that when we're working with the variance, you're basically going to have expected value of x minus mu all squared, which is the same thing as expected value of x minus mu, s minus mu. But when you're working with the covariance, you're going to have expected value of x minus mu, then y minus mu. Look at that. That's what you have now. Take a look at that. So I just gave you how to get the covariance when s and y are discrete, when s and y are continuous. Okay. And we actually have a proof, okay, for the covariance. This is what I just that I talk about, that expected value of xy. Okay, the covariance will be equal to expected value of xy minus the mu of s and the mu of y. Anytime you see something like this, mu s means expected value of x, mu y means expected value of y. And then if you see sigma squared s, that is the variance of x. Sigma squared y, that is the variance of y. Sigma x y, that is basically going to be covariance xy. Take a look at that. We play with notations a lot, Now, what am I doing here? We are back at discrete example. Maybe they wanted to figure out, the question is to compute the covariance. And the fact that you know that the covariance formula, okay, the covariance formula, whether you are dealing with discrete or you're dealing with the continuous, the covariance formula is sigma xy will be equal to expected value of xy minus expected value of x multiplied by that. Then it means you need to first figure out the expected value of the product that I showed you the other time. You already know how to get the expected value of x. You already know how to get the expected value of y. Take a look at what I presented to you. We got the mu of x. You get the mu of y. You get the expectation of the product. I showed you the other time how to get the expectation of the product. That is what I was explaining. I'm going to show you now. Expectation of the product for discrete case. That's what I was doing here. Okay, so in the end, you see what happened now, right? Okay, so finally you got your covariance to be -9/56. The -9/56, the fact that this is not 0 indicate that x and y are not independent. Because for x and y to be independent, the covariance of x and y has to be equal to 0. What do I mean by covariance? The covariance is talking about, the variation. It means the variation, between x and y. But the variance of x is the variation within x. The variance of x is, let me take you back to the machine A, machine B. Machine A does not produce the same things in different operations. Machine B does not also produce the same thing in different operation. Then when I want to talk about the variation within machine A in terms of what machine A produce, that is a variance of, the variance for that. I will be looking for the variance. If I want to look at, the variation within that of machine B, if I call that Y, that would be sigma square Y. What if in a situation where I want to put them together now? What is it? Is there any variation between them? That is co-variance, which we call covariation. And that's exact, and this is negative. When your covariance is negative, your correlation will be negative. When your covariance is positive, your correlation will be positive. So if I want to, how am I going to get, the correlation? I'm going to give you the formula for the correlation now, because correlation actually measures the degree of positivity or negativity of the relationship between two variables. It's going to tell us the strength and the direction. The strength in terms of, is it weak? Is it strong? Is the relationship perfect? The direction in terms of, is it negative? Is it positive? Okay, now the correlation that I talk about, which is the rho XY, is basically going to be covariance divided by the square root of sigma square S, sigma square Y. Look at that. The square root here is the standard deviation of S. The square root here is standard deviation of Y. Look at that. This is a formula for correlation. Of course, the denominator will always going to be positive, which means the sign of the correlation depends on the sign of the covariance. Any question? So which means right now, you can compute the correlation because you know how to do this guy. You know how to get the sigma square. For X, you know how to get the sigma square Y. Okay, so this is when you have continuous, and the question is asking you to get the covariance. Of course, you don't forget you have the f of xy, the joint. Okay, and when you have the joint, you need to follow first, because you need the covariance. To get the correlation, you do a lot of stuff. You need the covariance, and don't forget the covariance that you need. This is the formula. It means I need the expectation of the product. I need this guy, and if I want to get this guy, I need f of s. If I want to get this guy, I need f of y. If I want to get this guy, I'm basically going to use the f of xy. Okay, so the g of s that you see is what you derive from the f of xy, where you integrate over the range of y. The h of y that you see is is a marginal density function of y when you integrate, when you perform the antiderivative of the joint with respect to x. After getting that will provide a way to get the expectation of s and the expectation of y, which is what is required. This guy. Then the next, now you want to figure out the expectation of the product, which is what you're doing here. Finally, you will be able to get your covariance by plugging that in. What I have now is 4 over 2 to 5. That's a positive. That's a positive sign. Then I can come into the correlation. If they ask me correlation, I'm going to put this guy. But, I need the variance. Don't forget what we did the other time. If I basically want to get, if I want to get the variance, okay, sigma square x is going to be expected value of s squared minus expected value of x all squared. Then the sigma y squared, expected value of y squared minus expected value of y all squared. Don't forget that. And that is why I said, oh my God, all what we're doing, they are mathematical expectation. Whether the mean, whether the variance, whether the covariance, whether the correlation, they are all mathematical expectation. So take a look at that. Okay. Look at it now. You got your, and to get your variance, you need this guy. And this guy, you already compute this. So that's what we're doing now. Finally, you get a correlation. How do you know your correlation is right? The correlation value that you're going to get must lie between -1 and +1. Any question? I don't want to rush you. This objective, I'm actually going to walk you through this elective on Tuesday. I mean, this objective on Tuesday, this is now take a look at this. Oh, when I have X and Y, what are the possible algebra? Or let me just say, what are the possible algebraic operations that can be performed on X and Y? Number one, I can add, that is X plus Y, right? Number two, I can subtract, that is X minus Y. Number three, I can multiply, that is X, Y. Number four, can somebody tell me? What is another algebraic operation I can perform on X and Y? Okay, let me just tell you, I said we got X and Y. Give me 1 second. I'm actually, I'm gonna. If I have X and Y, the first algebraic operation, I'm talking about possible algebraic operation that can perform on X and Y. We can do X plus Y, right? We can do X minus Y. We can do X times Y. Can somebody tell me the next one? X divided by Y. Send me a message for extra credit. X divided by Y is a ratio. We cannot perform that. That one is a non-linear. Every other one is linear. All of this, we say about linear combination. But when you have a ratio, it is non-linear. And you know what? The non-linear will need approximation. We can't get exact results. And that's why we're going to go into Taylor series of approximation. I'm going to start that on Tuesday. Oh my God, start is easy. But start is easy to follow when you understand the story. Understand everything behind the scene. Like, why am I doing what I'm doing? I don't just do maths. There's a reason I can relate what I'm doing. A nonlinear approximation, the nonlinear requires approximation, but linear does not require approximation. That's going to be easy. But the nonlinear, of course, we're going to use like going to Taylor series. So how do I find the mean of a ratio? How do I find, and somebody may want to ask me, why am I interested in ratio? Oh, maybe I'm interested in ratio. For instance, when you talk about the ratio of life expectancy, the ratio of the potency of a drug. The potency of a drug, like in treating a certain medical condition, right? I have a drug S, or let me say, I'm proposing a new drug, Y, but there's a particular drug in the market, X. This one is the one currently in the market. This is a new drug. Why am I interested in the ratio? I actually want to determine maybe the potency. What is the potency of the new one compared to this? When the ratio equal to 1, you know what it means? When the ratio equal to 1, they are equally potent. But let me tell you this. This is not what we want. Those who are proposing this, you know what they want? They want something greater than 1. If it is less than 1, that is worst. Does that make sense? When you are doing all this and you relate, I remember when I was learning statistics, mathematics in Africa, I'm going to tell you what my professor is telling me doesn't make sense to me until I relate to real life. You always make sure you relate, follow whatever you learn with practical mind, not just theoretical mind. With a theoretical mind, it's going to look more abstract. And that's why my daughter in high school and middle school, they're going to come home and say, Dad, this is jargons. X plus Y equal to 5. What is it meaning? I'm going to say, okay, daughter, sit down. Let's say X represent the price of cookies. And my daughter is saying, I know cookies. And let's Y represent the price of candies. I know candies. And you know what? The fact that she really understands the reason why you are doing what you are doing, you will do it more. You will appreciate what you are doing. What if you are learning maths without, you don't really know what you are doing? You're just learning maths, you're just doing maths. That doesn't make sense. And that's why you have to make sure when you relate, when you are applying, relating is like you are applying it because you're applying it to what you see every day. Any question today? Any question? So, like I said, Monday, I want everybody to be on ground because Monday we'll be committed to meet and one practice review. I'm going to go over those questions with you in class. I'm going to tell you, give you some information. Let me tell you this privileged information. I'm also going to align an online option in this exam, but why